Hi. In this question, this is an equation problem. We have a complicated looking equation whose roots are alpha as a function of a and beta as a function of a. And we have a greater than 0. A is greater than 0 condition is given so that the roots are always defined. There is a square root here, there is a sixth root here. It will not be possible if a is less than -1, right? So you are ensuring that a is greater than 0. And alpha a is the bigger root, beta a is the smaller root. Once we find the roots of this equation, we have to minimize this expression, f of a, right? So the first job here is obviously to solve for the equation, right? This equation looks very complicated. So, and you can see that the powers are 1 by 3 here, 1 by 2 here, 1 by 3 here, 1 by 6 here. So let's take a simple substitution. T is equal to sixth root of 1 plus a, because that will ensure that all the radicals will get removed, right? So this part will be t square minus 1 x square plus 1 minus t cube x plus t square is equal to t, right? So if you simplify this equation a little bit, you will bring everything to one side and try to make it a quadratic. So we'll get this plus t square minus t is equal to 0, right? Now, if you notice, since a is greater than 0, we know that t is greater than 1. T is greater than 1, right? If t is greater than 1, t minus 1 cannot be 0, can't be 0. If t minus 1 can't be 0, we can cancel that factor, right? We can cancel that factor without any errors. So if we cancel that factor from each of these terms, you'll get t plus 1 x square and t minus 1. So this expansion is 1 minus t into something. So it will be minus of 1 plus t square x. And then t minus 1 again. So that will be t into t minus. So plus t equal to 0, right? This is my situation. Now, if you look at this quadratic equation, obviously you can use the quadratic formula to solve it. Although we can know that alpha and beta are the roots, then alpha plus beta should be negative of, so 1 plus t square by t plus 1, and alpha into beta should be t by t plus 1, right? So if you think about it, this sum of the roots is actually becoming 1 plus, this is 1 plus t common t plus 1 by t plus 1, so which is basically t plus 1 by t plus 1, right? Sum of the roots is t plus 1 by t plus 1, and product of the roots is t by t plus 1. So you can even see that the roots are t and 1 by t plus 1. These are the roots, right? Because sum of the roots will also fit and product of the roots will also fit. If you're not convinced, just solve the quadratic for x, right? By the quadratic formula, you'll get these roots. Now, we know that alpha a is bigger than beta. So which one is bigger? T is obviously going to be bigger than 1 by t plus 1 because t is greater than 1 here, right? So for greater than 1 values, t is bigger. So basically our roots are alpha should be t and beta should be 1 by 1 plus t, right? And now what was our alpha? Alpha was sixth root of 1 plus a, right? So I will just write it on the next screen. We have alpha is equal to t and beta is equal to 1 by 1 plus t. These are the roots of the equation where t is equal to sixth root of 1 plus a. And what do I have to minimize? The expression that I have to minimize is alpha a plus 12 times beta a, alpha a plus 12 times beta a, plus we have 4 by alpha a, 4 by 9 alpha a and beta a square, right? This is what we have, correct? So let's just write it once. Alpha a is simply t. So that will be 1 plus a sixth root plus 12 times beta a. So 12 by 1 plus sixth root 1 plus a, right? Plus 4 by 9. Alpha a is t. That is sixth root of 1 plus a. And beta square will become 1 by on top 1 plus root over 1 plus a sixth root whole square, right? So basically this looks like the expression that we have to minimize this, right? Now, obviously, we know that both alpha and beta are positive. Both alpha and beta are positive because t is greater than 1 in this problem. So when we have positive things, a way to minimize would be AMGM inequality, right? Notice that if we have to do AMGM, I want all of the A parts to get cancelled out, right? All of the A stuff should get cancelled out. So this will get cancelled with this, and this can get cancelled with this. But the problem is that there is only one factor here, and there are two factors here, right? So if you want to do it properly, you should split this middle term, right? So we can write it as 6 by 1 plus root over 1 by a plus 6 by 1 plus root over 1 plus a, and this we'll keep it as it is, and we'll say plus 4 by 9 1 plus 6th root of 1 plus a whole square by 6th root of 1 plus a. This is the same expression as the previous one, but what we have done, we have split this term so that we have two terms with this. So when we do AMGM, it will work out very nicely because these will cancel this part, right? What is AMGM going to say? It is going to say that sum of all these 4 divided by 4 is greater than the 4th root of the product, right? So we can say that this whole thing is S. We can say S by 4 is greater than equal to the 4th root of the product of these terms. What is the product of these terms? Let's see that. This is 6th root of 1 plus a multiplied by 6 by 1 plus 6th root of 1 plus a multiplied by 6 by 1 plus 6th root of 1 plus a multiplied by 4 by 9, and we have 1 plus 6th root of 1 plus a whole square by 6th root of 1 plus a. So notice this is why we split it into two terms here, because now this and this get cancelled with this gets cancelled with this, and you have 36 and 9, so that becomes 4, and so this is 16th, 4th root of 16, right? So greater than equal to 4th root of 16, which is equal to 2, S is coming as greater than equal to 8, right? So the minimum value of this is 8, right? So M is 8, so GIF of M is also 8. So that becomes your answer. Again, the problem is actually very easy. The key things in the problem are what? Take this thing as a variable, solve quadratic, by simple methods. You'll get x is equal to t, alpha is equal to t, and beta is equal to 1 by 1 plus t. Once you do that, you have to minimize by AMGM. Minimize by AMGM method, right? And to minimize here, you will have to split the 12 term into two parts, 6 and 6. Why? Because you need two factors like this in the denominator to cancel everything, right? So that is the solution for this problem. This is also a test series question from Alan. So hopefully like this will help you guys, and we will come back and meet you in the next video. There is more content in my problem solving series. If you like the content, please like the channel, subscribe to the videos, and hopefully I'll see you in the next video.